In our previous classes, we have seen that what algebraic expressions are. So when we are combining the constants and variables along with the operations, mathematical operations, that is your addition, subtraction, multiplication and division, the expression which we are getting is your algebraic expression. The example we can take it as, like if we are writing 2x square plus 3x plus 7. So over here 2 is a constant because the value of 2 will remain 2. We cannot write 2 equivalent to 3. The 3 over here, the 7 over here, all these are constants because its value remains same. Whereas the x is the variable because we can keep any value of x in the expression. So when we are combining these your constants and variables together along with the operations, like over here we have taken addition sign, 2 is multiplied by x square, so over here we have taken multiplication sign. So when we are combining constants and variables together using the mathematical operations, we are getting the algebraic expression. So over here we can see that this 2x square is one of the term of the expression, 3x is another term and 7 is another term. When these terms are added or subtracted together, we are getting the different terms. Over here we can see that 2x square is one term, 3x is another term and 7 is another term. These terms are joined together either with the operations of addition or with subtraction. We'll be getting an algebraic expression. When we are multiplying the variables and the constants, we are getting a term. That means it is over here 2x square is one term because 2 is multiplied by x multiplied by x. Whenever we are multiplying the constants and variables or we are dividing the constants and variables, we are getting a term. Similarly, we are going to say if it is written like 2x by 7 plus 3x square plus 9. So over here 2 over 7, 2x over 7, it is even a one term because over here constants and variables are multiplied or divided. Whenever they are multiplied or divided, we are getting a term, and whenever we are adding or subtracting, we are getting the separate terms. So this is one of the term, this is another term and this is another term. So when these terms are added or subtracted, we are getting an algebraic expression. Now what is polynomial? Polynomial is a specific type of algebraic expression where the exponent of the variable will be a whole number. In the algebraic expression, the exponent could be 2x raised to the power minus 3 is even an algebraic expression. 2x raised to the power 3 by 7 is also an algebraic expression. But these are not the polynomials. Whenever your variables, the exponent of the variable is becoming either your negative or in fraction, it will not be the part of your polynomials. It will be the algebraic expression, but it will not be the polynomials. That means polynomials are the special cases of the algebraic expressions where the exponents of the variables are your whole numbers. That means the variable, the exponent of the variable could be 0, could be 1, could be 2, could be any positive number or could be 0 also, but it cannot be negative, it cannot be in fraction. So it must be clear to you that what is polynomial and what is the difference between an algebraic expression and a polynomial. Now let's see what is degree of the polynomial. Whatsoever is the maximum power, maximum exponent of the variable in the polynomial is the degree of the power, degree of the polynomial. Like if I am saying 3x raised to the power 7 plus 5x raised to the power 5 plus 7x. So here three terms are there. This is one term, this is another term, this is a third term. Over here in the first term, the power of the x, variable x is 7. In the second term, the power or the exponent of the variable is 5. In the third term, it is 1. So over here we can see that the maximum power of the variable is 7. So the degree of the polynomial will be 7. So whatsoever is the maximum power of the variable is there in the polynomial, that is the degree of the polynomial. So from here it is clear that the degree is 7. If we are going to take another example, we can take it as x 5x raised to the power 3 plus 7 x raised to the power 5 plus 3. Over here we can see again there are three terms are there. This is one term, this is another term, and this is the third term. In this first term the degree is 2 variable. The exponent is your exponent is having the your variable is having the exponent as 3. Here variable is having the exponent of 5, and here there is no variable part. So maximum power over here in this polynomial is 5. So the degree of this polynomial will be 5. Hope it is clear that how to find the degree of the polynomial. Now let's see what zero polynomials are. Zero polynomial, if we are writing only 0, if this is your algebraic expression or if this is the polynomial, 0 is the polynomial, then this is known as zero polynomial. Zero polynomial is 0 itself is the zero polynomial, and the degree of the zero polynomial is not defined. The degree of this zero polynomial is not defined. We cannot find the degree of this zero polynomial because 0, if it is going to multiply by any number, any variable, the result will be 0 itself. That's the reason the degree of zero polynomial is not defined. Now let's see what is constant polynomial. When in the polynomial there is only constants are there, there is no part of the variable, such type of polynomials are known as constant polynomials. Like if we are going to take an example, if I am going to say 2 upon 5, there in this it is even a polynomial. So in this polynomial constant is 2 upon 5, but there is no variable part. So such type of polynomials are known as constant polynomials. Instead of this we can take it as minus 3. It is even a constant polynomial. Then we can take it as 5. It is even a constant polynomial. So all these are your constant polynomials. It could be negative, it could be positive, it could be in friction. All these are the examples of constant polynomials. And the degree of the constant polynomial is 1. Sorry, the degree of the constant polynomial is 0. The degree of this constant polynomial is 0. Why so? Because see, 2 upon 5 could even be written as 2 upon 5 x raised to the power 0. As we know that in the exponents we have learned that if there is any variable with the power 0, in that case its value will be 1 only. So we can say x raised to the power 0 is 1. Any variable with power 0, its value is 1 only. So x raised to the power 0 is 1, and 2 upon 5 multiplied by 1 is 2 upon 5 itself. That's the reason we can write 2 upon 5 as 2 upon 5 multiplied by x raised to the power 0 also. We can write minus 3 as minus 3 multiplied by x raised to the power 0 also. And just now we have learned that whatsoever the power of variable is there, that is the degree. Over here the power of the variable is 0. That's the reason for constant polynomials degree will be 0. Now let's see what is linear polynomials. Linear polynomials are the polynomials whose degree is 1. The polynomials with degree 1 are known as linear polynomials. The general formula for the linear polynomial is ax plus b. It is the general standard form of your linear polynomials. Here x is the variable, a is the coefficient of the variable, and b is the constant number. The general form of this polynomial is ax plus b, and a should not be 0 and a and b are any real numbers. If a and b are any real numbers and a is not equivalent to 0, then ax plus b is the general form of the linear polynomials. If we are going to see the quadratic polynomials are the polynomials whose degree is 2. The general form of this your quadratic polynomial is ax square plus bx plus c, where a should not be 0 and a, b, c are any real numbers. We can take the example of this linear polynomial as 2x plus 3. We can see over here that the variable is x and the degree of this variable is 1. Variable is x and its degree is 1. 2 is the coefficient of x and 3 is the constant term. Similarly, for the quadratic polynomial, example could be 7x square plus 3x plus 4. Here we can see that in this term the power of the x is 2, here the power of x is 1, and here there is no variable part. So the highest power or the highest exponent of the whole terms is your 2. That's the reason degree of this polynomial is 2, and such type of polynomials are known as quadratic polynomials. If we are going to see over here, here we are saying that a should not be 0. Here even we have said that a is not 0, means a cannot be 0. Why it is so? Because see, if a is 0, in that case this term will turn to 0. And if this term is 0, that means remaining will be your b only, and b is a constant polynomial. It is not a linear polynomial. That's the reason the value of a cannot be 0 in this ax plus b for a linear polynomial. If it is to be a linear polynomial, then a cannot be 0. And here we can see that the maximum number of terms is your 2. Number is your 2. Maximum numbers of the term is 2 in this polynomial. In this, see, 7x square. 7 is your value of a is 7. So if a is 0, in that case your this term will become 0. And if this term is 0, in that case it will be your 3x plus 4, which will be a linear polynomial, which will not be a quadratic polynomial. That's the reason a cannot be 0. And maximum number of terms for a quadratic polynomial is 3. 1, 2, 3. Maximum number of terms is 3. Maximum terms will be 3. It could be 2 also. It could be 1 also. If we are going to see 5x square plus 3 is also a quadratic polynomial. Similarly, 3x square is also a quadratic polynomial. Here number of terms is 2. Here number of term is 1. So minimum it will be 1, but maximum it could be 3. Not more than 3. Not more than 3 number of terms is possible for a quadratic polynomial. Now let's see what is cubic polynomial. Cubic polynomials are the polynomials whose degree is 3. So if degree is 3, its standard form will be ax cube plus bx square plus cx plus d will be the standard form for the cubic polynomial. Over here, a is the coefficient of x cube, b is the coefficient of x square, c is the coefficient of x, and d is the constant term. Again the same thing. Here a cannot be 0, and a, b, c, d are any real number. Because again the same thing, because if a will become 0, in that case this term will be 0 and this will remain your quadratic polynomial, not a cubic polynomial. That's the reason a cannot be 0. For this, even if we are going to see the number of terms, maximum number of terms could be 1, 2, 3, 4. Maximum number of terms could be 4. Example, we can take it as 3x cube plus 4x square plus 5x plus 7. This is an example of a cubic polynomial. So maximum number of terms is 4. Minimum number of terms will be 1. That is your, suppose 5x cube. It is even a cubic polynomial and it is having the number of terms as 1. Another examples could be your 7x cube plus 3x. It is even a cubic polynomial and over here number of terms is 2. So we can see if it is a linear polynomial, maximum number of terms is 2. If it is a quadratic polynomial, maximum number of terms is 3. If it is a cubic polynomial, maximum number of terms is 4. That means whatsoever the degree of the polynomial is there, the number of terms will be, if the degree of the polynomial is n, in that case your maximum number of terms will be n plus 1. It will be 1 more than that. For degree 1 it was 2, maximum terms were 2. For degree 2 maximum number of terms were 3. For degree 3 maximum number of terms was 4. So we can see if the degree of the polynomial is n, in that case maximum number of terms in that polynomial could be n plus 1. And minimum number of terms will be, if we are going to say the minimum number of terms, so minimum number of terms will be 1. If there is only one term, then also it could be a linear polynomial, it could be a quadratic polynomial, it could be a cubic polynomial. Now let's see what is biquadratic polynomial. A polynomial whose degree is 4. Polynomial with degree 4 is known as biquadratic polynomial. Its general form is ax raised to the power 4 plus bx raised to the power 3 plus cx square plus dx plus e. It is the general form of a biquadratic polynomial. Here we can see again a cannot be 0 and a, b, c, d, e are any real numbers. If this is the condition, such type of polynomials are known as biquadratic polynomial. In quintic polynomial, the quintic polynomials are the polynomials whose degree is 5. So general formula for this is a x raised to the power 5 plus b x raised to the power 4 c x cube d x square e x plus f. This is the general form of quintic polynomial where a cannot be 0 and a, b, c, d, e and f are any real numbers. Now let's see what is value of the polynomial. If there is a polynomial px which is in terms of x only, if px is a polynomial in x and if we are going to take k as any real number, then value obtained by replacing x by k will give us in px, it will give you value of px at x is equivalent to k and is denoted by pk. So if we are going to take any polynomial px, suppose I am saying it to be 2x raised to the power 2 plus 5x minus 2. If this is a polynomial in terms of x and we have to find the value of p1, that means here value of k is 1 and if we are replacing this x by 1, we will be getting the value of the polynomial at x is equivalent to 1. Now if we will replace all the x here by 1, we will be getting 2, 1 square plus 5 multiplied by 1 minus 2. 2 multiplied by 1 square will be 2 only plus 5 minus 2, that will give you 5. So value of the polynomial, this was the polynomial, in terms of x it was, and we have replaced this x by any real number. Here the real number we have taken as x. So if we will replace the variable with the given real number, then whatsoever the value we will be getting, it will be the value of the polynomial at x is equivalent to k, that is over here at x is equivalent to 1. So value of this polynomial at x is equivalent to 1 is 5. Similarly, if we are going to take any other polynomial, suppose the polynomial is 3x square plus 2x. If this is a polynomial and we have to find its value at 2, at x is equivalent to 2. In that case, what we will be doing is, wheresoever x is coming in the polynomial, we will replace it by 2. So, the value will be of p2 now. So P2 will be 3 multiplied by 2 square plus 2 multiplied by 2. Wheresoever x was coming, we have kept it as 2. So square of 2 will be 4. 4 multiplied by 3 will be 12 plus 2 multiplied by 2 will be 4. 12 plus 4 will be 16. So value of the polynomial, this polynomial 3x square plus 2x at x is equivalent to 2 is 16. So value of the polynomial will be 16 when you are replacing x by 2. So that's the reason the value of the polynomial we can find by replacing the variable by the given real number. Now let's see what is 0 of a polynomial. So the real number k is called 0 of the polynomial px if pk is equivalent to 0. Just now we have seen that if there is a polynomial px in terms of x and if we are replacing this x by any real number k, we are getting the value of that polynomial at x is equivalent to k. The value of k for which the value of the polynomial becomes 0 if the value of the k is whatsoever the value of k is there, if the value of the polynomial becomes 0, then this k is known as 0 of the polynomial. Let's understand this by example. Suppose The polynomial in terms of x is 2x plus 7. This is the polynomial in x. If we are going to keep x is equivalent to minus 7 by 2. This is a real number. Suppose the value of k over here is minus 7 by 2. So if we are going to replace this x by minus 7 by 2, so what the value will come? P minus 7 by 2 will be 2 multiplied by minus 7 by 2 plus 7. 2 and 2 both are going to cancel. It will be minus 7 plus 7, that is 0. So here the value of k for which the value of the polynomial has become 0, this k is known as 0 of the polynomial. So the value for which the polynomial becomes 0, whatsoever the value of k is there, any real number for which our polynomial, the value of the polynomial is becoming 0, is known as 0 of the polynomial. Another example we can take it as, suppose we have taken px is equivalent to x square minus 3x plus 2. If we are going to take over here at x is equivalent to 1, we are finding the value of the polynomial. So we will replace this x by 1. So p1 will be x square minus, this is the polynomial, we are writing it as, this is in terms of x. Now if we are replacing this x by 1, this will become 1 square minus 3 multiplied by 1 plus 2, that will be 1 minus 3 plus 2, 1 plus 2 will be 3 minus 3, that is 0. So when we are keeping x is equivalent to 1, the value of the polynomial is becoming 0. So that's the reason 1 is the 0 of the polynomial. So the value of the k for which value of the polynomial is becoming 0, that k is known as 0 of the polynomial. Now let's understand for linear polynomials. If we are considering linear polynomial, as just now we have seen that the general form of the linear polynomial is ax plus b. If this is the general form of the polynomial, so the value of the 0 of this polynomial, how to get it? For finding this, the value of this polynomial should be 0. So we are keeping it as ax plus b equivalent to 0. So x will be minus b by a. We can write it as, one more step we can write, ax is equivalent to minus b, or we can say x is equivalent to minus b by a. So if we are replacing in this polynomial, in this linear polynomial, if we will replace this x by minus b by a, our polynomial will become 0. So this value of the x is the 0 of the polynomial, or we say it as root of the polynomial. So just check it out. Over here, if we will replace x by minus b by a, the polynomial over here, polynomial in x is ax plus b. If we will replace this x by minus b by a, it will become a multiplied by minus b by a plus b. A and a both cancelled. It will be minus b plus b, that is 0. So for linear polynomial, the 0 of the polynomial is minus b by a if the linear polynomial is your ax plus b. So we can say the 0 of the polynomial for your linear polynomial is, here b is constant term. So minus of the constant term divided by a. A is the coefficient of x. Coefficient of x. So for a linear polynomial, the 0 of the polynomial will be minus of constant term divided by coefficient of x. This will be the 0 of the polynomial for linear polynomials. Now let's see the values of a quadratic polynomial. How to find it out? As just now we have seen that the quadratic polynomials are the polynomials whose degree is 2. And the general form of the quadratic polynomial is ax square plus bx plus c, where a should not be 0 and value of a, b and c are real numbers. So for finding the zeros of a quadratic polynomial, we have to factorize it. So just take an example to check it out how to find the values of a quadratic polynomial. Suppose a quadratic polynomial is x square minus 5x plus c. Now we have to find the 0 of this polynomial. That means we have to find the value of the x for which this polynomial will turn to 0. For that, we will keep it equivalent to 0. We will keep the value of this polynomial equivalent to 0. Now, we will be factorizing it by middle term splitting. So, it will be x square minus 2x minus 3x plus 6 equivalent to 0, or we can say from these two x could be taken common, x minus 2 from the last two terms minus 3 could be taken common, and it will be x minus 2 equivalent to 0. From here x minus 2 could be taken common and x minus 3 equivalent to 0, or we can say from this that x is equivalent to 2. From here we can say x is equivalent to 3. That means 0 of this polynomial, this quadratic polynomials are 2 and 3. That means for these two values of x, this polynomial will become 0. If we are going to keep x is equivalent to 2, then also this polynomial will become 0. And if we are going to keep x is equivalent to 3 in this polynomial, then also its value will become 0. So by this factorization method, we can find the zeros of the polynomial. From here, it must be clear that for a linear polynomial, if we are going to take a linear polynomial, the maximum number of zeros is 1. For a quadratic polynomial, if we are going to take the quadratic polynomial, in that case, maximum number of zeros will be 2. For a cubic polynomial, the maximum number of zeros will be 3. It could be less than this also. Means for a quadratic polynomial, it is even possible that the number of zeros is 0 and 1 also. Means there is no value for x, no value of x for which your polynomial will become 0. And it is even possible that there is only one value of x for which this polynomial will become 0. But at the max, we will be having only two values of x for which this quadratic polynomial will become 0. Similarly, if we are going to take any cubic polynomial, then at the max there are three values of x for which the polynomial will become 0. It could be 0 also, means there is possibility that there is no value of x for which the polynomial will become 0. And it is even possible that there is only one value of x for which the polynomial will become 0. There could be two values also for which the polynomial will become 0. But at the max, for a cubic polynomial, there will be three values of x for which the polynomial will become 0. That means if the degree is n, if the degree of a polynomial is n, then the maximum number of zeros will be n only. For a linear polynomial, we are having degree 1, so maximum number of zeros is 1. For a quadratic polynomial, degree is 2, so maximum number of zeros will be 2. For a cubic polynomial, degree is 3, so maximum number of zeros will be 3. Hope it is clear to you. Now let's see what is the relation between zeros and coefficient of a polynomial. Here we will be talking about quadratic polynomial. For linear polynomial, just now we have discussed that for linear polynomial, there is only one zero is there, and the value of that one zero will be minus b by a if your polynomial is ax plus b. That is, your polynomial, zero of the polynomial will be minus b by a, where b is the constant term and a is the coefficient of x. So 0 will be minus of constant term divided by coefficient of x. It is for linear polynomial. Now let's see for a quadratic polynomial. For quadratic polynomial, as just now we discussed, that the maximum number of zeros will be 2. Maximum 2 zeros will be there. So if one of the zero is alpha and another zero is beta, we are assuming that the two values of k for which the polynomial will become 0 are alpha and beta. These are the two zeros of the polynomial, of a quadratic polynomial. Then sum of these zeros, that is alpha plus beta, will be minus b by a, where your quadratic polynomial is ax square plus bx plus c. We have assumed the quadratic polynomial general form to be ax square plus bx plus c, where a is the coefficient of x square, x coefficient is b is the coefficient of x, and c is the constant term. Here again we know that a cannot be 0. Now if this is the condition, then the sum of the zeros will be minus b by a. That means sum of the zeros will be minus b. B is coefficient of x, that means minus of coefficient of x over a. A is the coefficient of x square. This is the relation of the zeros and the coefficient of polynomial. That means if there are two zeros in a quadratic polynomial, then sum of these two zeros will be minus b by a, where the general form of your quadratic polynomial is ax square plus bx plus c. That means sum of the zeros will be minus of coefficient of x over coefficient of x square. And product of zeros, that is alpha into beta, that will be c by a, where c is the constant term and a is the coefficient of x square. That is, the product of the zeros will be c is your constant term divided by a, that is your coefficient of x square. So we can say that in a quadratic polynomial, the sum of the zeros, if there are two zeros are there, alpha and beta are the two zeros of the quadratic polynomial ax square plus bx plus c, then sum of two zeros will be minus b by a, that is minus of coefficient of x over coefficient of x square, and the product of the zeros, that is alpha into beta, will be c by a, that is constant term over coefficient of x square. This is a relation between zeros and coefficient of a quadratic polynomial. Now let's verify it. Just now see, we have taken an example of a quadratic polynomial, that is x square minus 5x plus c. If we are going to compare this polynomial with this polynomial, we can see that the value of a over here is 1, because the coefficient of x square is 1 here. Value of b is minus 5, because b is the coefficient of x, that is minus 5, and value of the constant term, that is c, is 6, right? So from here we can see the polynomial ax square plus bx plus c, we will be comparing with these two this polynomial, that is x square minus 5x plus c. So from here we can see that the value of a is 1, b is minus 5, and c is 6. From this factorization method, we came to know that the polynomial zeros of the polynomials are 2 and 3. That means value of alpha, one of the zero is 2, and value of beta, that is 3. Two zeros are 2 and 3, and we have assumed the two zeros to be alpha and beta. So value of alpha we have assumed to be 2 and beta is 3. Now from here we are saying that the sum of zeros, that is your 2 plus 3. Sum of the zeros will be, sum of zeros is your 2 plus 3, that is 5. And here it should be minus of coefficient of x over coefficient of x square. So minus of coefficient of x, or you can say minus b by a. So minus of b by a is the sum of the zeros, and this is minus b value is minus 5, so we will keep it as minus 5. Value of a is 1, so we will take it as 1, and that is equivalent to 5. From here also sum of the zeros is 5, and from here also the sum of the zeros is 5. Now check for the product of the zeros. From here, if one of the zero is 2 and one of the zero is 3, so product will be 2 multiplied by 3, that is 6. And from here, if we will check, product of zeros alpha into beta is c by a. It is your c by a. Value of c here is 6 and value of a is 1, that is 6 only. So we can check from both the two methods that sum of the zeros is coming 5 and product of the zeros is coming 6. Now let's see what's the relation between zeros and coefficients of cubic polynomial. Just now we have seen the relation of zeros and coefficients of a quadratic polynomial. Now we will be seeing for the cubic polynomial. We have already seen that the general form of a cubic polynomial is ax cube plus bx square plus cx plus d, where a is not equivalent to 0. We have even discussed that for a linear polynomial, the maximum number of zeros is 1. For a quadratic polynomial, the maximum number of zeros is 2. Similarly, for a cubic polynomial, maximum number of zeros is 3. Now here we are assuming that the three zeros of a cubic polynomial is alpha, beta and gamma. These three are the zeros of the polynomial, that is a cubic polynomial, means these are the values for which the value of the polynomial will become 0. Now what is the relation between these zeros and the coefficients of the variables of your polynomials? Now here we can see that a is the coefficient of x cube, b is the coefficient of x square, c is the coefficient of x and d is a constant term. So sum of the zeros in a cubic polynomial, if there are three zeros, that is alpha, beta and gamma are the three zeros of a cubic polynomial, then sum of these three zeros will be minus b by a. That means the sum of the zeros will be equivalent to minus of coefficient of x square over coefficient of x cube, as b is the coefficient of x square and a is the coefficient of x cube. So sum of the zeros will be minus of coefficient of x square over coefficient of x cube. Similarly, if we are going to take pair of two zeros and if we will add all them, that means alpha beta plus beta gamma plus gamma alpha, we will be doing this. It will be equivalent to c by a, where c is the coefficient of x and a is the coefficient of x cube. That means the sum of all these three will be equivalent to coefficient of x over coefficient of x cube. Now the product of all the three zeros will be minus d by a. D is the constant term and a is the coefficient of x cube. That means product of all the three zeros will be minus of constant term divided by coefficient of x cube. This is the relation between zeros and coefficient of a cubic polynomial. Now how to find the zeros of a cubic polynomial? If any cubic polynomial is given to us, suppose I am saying that the cubic polynomial is x cube plus x square plus x minus 3. This is the cubic polynomial. Now we know that the zeros of the polynomial will be the values of the x for which this polynomial will become 0. So we are assuming that this polynomial is your px, and if instead of x we are going to keep 1 over here by trial and error method, we are keeping x is equivalent to 1. So p1 will be 1 cube will be 1 itself. We are keeping instead of x we are keeping 1 over here. So this will be 1 plus 1 minus 3, that is 3 minus 3, or we can say it will be equivalent to 0. So from here, by trial and error, by keeping the values of x over here, we have found that the one of the zeros of this polynomial is 1. Now once we are having this as the polynomial, if at x is equivalent to 1, this polynomial is turning to 0, that means x is equivalent to 1 is the root of this polynomial. That simply means x minus 1 is one of the factor of this polynomial. And when we will be dividing this polynomial by x minus 1, we will be getting a quadratic polynomial, and by using the method of factorization we can find the two more zeros of that particular polynomial. So this is how we can find the factors or the zeros of a cubic polynomial. Now if the quadratic polynomials, if we are having the zeros of the quadratic polynomial, how we can form the quadratic polynomial? Suppose just now we have discussed that if two zeros of a quadratic polynomials are alpha and beta. So sum of these these zeros will be your sum will be alpha plus beta. This is the sum of the zeros, and the product of the zeros will be alpha and beta. This will be the product of the zeros. So if zeros of a polynomial, a quadratic polynomial is given to us, then the equation, then the formation of the polynomial will be px will be k multiplied by x square minus sum of the zeros multiplied by x plus product of the zeros. this is the polynomial where k is any real number. Value of k is any real number. So if the zeros are given to us, we can find the sum of the zero also, we can find the product of the zeros also, and in this case the quadratic polynomial px will be k multiplied by x square minus alpha plus beta, where alpha and beta are the zeros of the polynomial, multiplied by x plus product of the zeros, that is alpha multiplied by beta. This will be the quadratic polynomial for which alpha and beta are the zeros. Now let's see what is the geometrical meaning of zeros of the polynomial. Till now we have seen the algebraic methods of finding zeros of the polynomial. Whatever the polynomial were, whether it was a linear polynomial or a quadratic polynomial or a cubic polynomial, using algebraic methods we have found the zeros of the polynomial. Now, how to find the zeros of the polynomial using geometrical method? Now see, as we know that the linear polynomial, the standard form is your ax plus b, and a should not be 0. And the zero of this polynomial is minus b by a. Minus b by a is the point at which this polynomial will become 0. If we are going to keep x is equivalent to minus b by a over here in this polynomial will become 0. Now, if suppose we have taken the polynomial as 2x plus 3. So, if we are going to keep x is equivalent to 1, we can find the coordinate for the y also. So, y will be 2 multiplied by 1 plus 3, that is 2 plus 3, that is 5. That means one of the coordinate is 1, 5. Similarly, if we are going to keep x is equivalent to minus 1, in that case y will be 2 multiplied by minus 1 plus 3. So it will become minus 2 plus 3, that is 1. So another coordinate which will satisfy this polynomial will be minus 1, 1. Now we are having these two coordinates. If we will plot these two coordinates on the graph paper, so we will be getting a straight line. For a linear polynomial, the geometrical representation is always a straight line. That means if we will be plotting this, something like this will be the graph. And as just now we have seen that the zero of the polynomial is your minus b by a. For a polynomial, linear polynomial ax plus b, zero of the polynomial is minus b by a. So by algebraic method we can say that the zero of this polynomial will be minus 3 by 2. By geometrical method, now we will see how we will find the value of x is minus 3 by 2. If we will plot these graphs, the point at which this will intersect the x-axis will be minus 3 by 2. That means the point at which the graph of the polynomial will intersect the x-axis will be the zero of the polynomial. As we know, for the linear polynomial, there is only one zero. So there will be only one point where the graph will intersect the x-axis, and the point at which it will intersect the x-axis will be the zero of the linear polynomial. Now let's see how to find zeros of a quadratic polynomial using geometric method. We know that the general form of a quadratic polynomial is ax square plus bx plus c, where a is not equivalent to 0 and a, b, c are any real numbers. Now we know that the quadratic polynomial could have maximum of 2 zeros, right? So what will be happening? Either there will be 2 zeros or 1 zero, or there will not be any zero of the quadratic polynomial. When we will be plotting the graph of a quadratic polynomial, its shapes is like a parabola. It could open upward also, it could open downward also. This is the shape of a parabola. When we will be plotting the graph of a quadratic polynomial, it will seem like this only. Now see, suppose we have taken a quadratic polynomial. Suppose it is your 2x plus 3x minus 5. For various values of x, we can find the value of the y also. We can write this polynomial equivalent to y. Now if we are going to keep x is equivalent to 1, we'll be getting some value for the y also. If we'll be keeping x is equivalent to minus 1, we'll be getting some value of y also. Similarly, we can find multiple coordinates of x and y which will satisfy this polynomial. When we'll be plotting all these coordinates in the graph, it will be, the shape of that will be a parabola. The shape of this will be parabola. If there are exactly two zeros of the polynomial, then it is going to intersect the x-axis at 2 points. At two distinct points it will be intersecting if there are two zeros of the polynomial. If the polynomial is having only one zero, then it will be intersecting at 1 point only. Then the parabola will intersect at x-axis at particularly 1 point only. It is not going to intersect x-axis at 2 point. It will intersect somewhere, but at 1 point only it will simply touch the x-axis. And if there is no zero of the polynomial, the graph of the polynomial is not going to intersect x-axis. That means the number of points the graph is intersecting your x-axis will give you the number of zeros, and the exact point at which it is intersecting the x-axis will be the zero of the polynomial. Suppose it is your 0, it is 1, it is 2, it is minus 1, it is minus 2. So 0 of this polynomial will be 2 and minus 2 will be the 0 of this quadratic polynomial. Suppose this point is your minus 3. So minus 3 will be the polynomial for this quadratic polynomial. This quadratic polynomial will have only one zero, and that will be minus 3. This polynomial will have two zeros, and the zeros will be 2 and minus 2. And this quadratic polynomial will not have any zero. So by seeing the graph, we can come to know that how many zeros the polynomial will have and what will be the value of that particular zero. By this we can find it out. Now over here, now if you will compare this, if you will be taking this general form, if the value of a is greater than 0, if the value of a is greater than 0, then the shape of the parabola will open upwards. Then the shape will be like this. It is going to open upwards, and if the value of a is less than 0, in this case the shape of the parabola will open downwards. It will be somewhere like this. So it should be clear that if the value of a is greater than 0, it will open upwards. The shape of the parabola will open upwards, and if it is less than 0, it will open downwards. And maximum of two zeros a quadratic polynomial could have. It could have one also. It is even possible that it is not having any zero. By seeing simply the graph, we will come to know that how many zeros are there, and the point at which it is intersecting the x-axis will give us the value of the zero also. Now similar as it is in quadratic polynomial, we are having two number of zeros. Similarly, in a cubic polynomial, at the max we can have three number of zeros. It is even possible that there are two zeros in a cubic polynomial. It is even possible that there is one zero in the polynomial. It is even possible that there is no zero of the polynomial. For a cubic polynomial, the graph will be, if it is having three zeros, it is going to intersect the x-axis at three distinct points. It will be like this. So this is one point, this is another point, this is third point. So it is going to intersect, the graph of the cubic polynomial will intersect the x-axis at 3 points if it will be having three zeros. If it is having two zeros, it will intersect the x-axis at 2 points. If it is intersecting it at 1 point, then it will be having 1 zero. And exactly the point at which it is intersecting the x-axis will give us the value of the zero. This is how by geometrical representation also we can come to know that what will be the zero of the given polynomial. If it is a degree of 4, if the polynomial is having degree 4, so it will be intersecting your x-axis at 4 distinct points. It may, because it could have even 4, maximum of 4 zeros it will have. It could have 3 also, it could have 2 also. So at the max it will be intersecting the x-axis at 4 distinct points if the degree of the polynomial is 4. Now let's take some examples related to what we have learned till now. Find the number of zeros and values of the zeros. Here we can see that this graph is intersecting x-axis at 1, 2, 3, 4, 5 points. That means this polynomial will have 5 zeros. The number of times the graph is intersecting the x-axis will give us the number of zeros, and the zeros will be the point at which it is intersecting will be the zeros, and it is intersecting at -6, -3, it is -4 here, -6, -4, this is the point as -2. Here it is intersecting at 1 and 3. So these are the zeros of the polynomial, the points at which the x-axis, at which it is intersecting the x-axis, the graph, that points will give us the zeros. And it is intersecting at 5 distinct points. That's the reason this will have 5 number of zeros. Here we can see that the graph is not intersecting the x-axis at any points, so the number of zeros will be 0. It won't have any zero. There won't be any zero for this polynomial. Here we can see that the graph is intersecting x-axis at exactly 1 point. So this will have 1 0 and the 0 will be -1. The value of the 0 will be -1. Now the second question is, write quadratic polynomial if sum of zeros is 9. So for quadratic polynomial we are assuming that the zeros are alpha and beta are the two zeros, because at the max it could have two zeros. So we are assuming that the zeros are alpha and beta. So sum of the zeros is given to us as 9. That means alpha plus beta, value of this is given to us as 9, and the product is 20. That means alpha into beta is given to us as 20. We know that the quadratic polynomial will be k if it is in terms of x. So px will be k multiplied by x square minus sum of the zeros multiplied by x plus product of the zeros, where k is any real number. So k x square, value of alpha plus beta, sum of the zeros is 9, so minus 9x plus product of the zeros is 20. So we'll be writing over here 20. Now we are assuming that k is equivalent to 1. We are assuming that k is equivalent to 1. So polynomial will be x square minus 9x plus 20 will be the polynomial whose zeros will be, sum of the zeros will be 9 and the product will be 20. Now let's take one more example. Find the zeros of quadratic polynomial 7x square minus 4x minus 3 and verify. Here the polynomial is 7x square minus 4x minus 3 is the polynomial in x. If we will compare this with the general form of the quadratic polynomial, that is ax square plus bx plus c, what we can say is that value of a is 7, value of b is -4 and value of c is -3. These are the values of a, b, c when we will be comparing these two. Then we have to find the factors. That means we have to find the zeros of this polynomial. For finding the zeros of this polynomial, we will keep it equivalent to 0, because 0 of the polynomial is the value of the x for which this polynomial will become 0. So we have kept it equivalent to 0. Now by middle term splitting, we will find the values of x. So we can write it as 4 could be written as 7 minus 3 x minus 3. We have to split minus 4x in two parts such that sum of these two should be equivalent to minus 4x and product should be equivalent to the product of the first and third term. That is 7 into minus 3, that is minus 21 x square should be the product, and the sum should be equivalent to minus 4x. So we have written this equivalent to minus 7 minus 3x. So 7x square minus 7x plus 3x, this minus will be multiplied by both of them. So this will come. Now from the first two terms, 7x could be taken common. Remaining will be x minus 1. From the last two terms, plus 3 could be taken common. It will be x minus 1. So x minus 1 is common again. It will be 7x plus 3. It is equivalent to 0. Now if we will take this part, that is x minus 1 equivalent to 0. From here we will be getting x is equivalent to 1. This is one of the 0. From this 7x plus 3 equivalent to 0. If this is the part we are taking, then 7x will be equivalent to minus 3 and x will be equivalent to minus 3 by 7. This is the another 0 of the quadratic polynomial. Now assuming this to be alpha and this to be beta. Now for verification, alpha plus beta should be equivalent to minus b by a and alpha beta should be equivalent to c by a. We have learnt already that the sum of the zeros is minus b by a for a quadratic polynomial and the product of the zeros is c by a. Now if we will add these two here, so x, if we will be adding, the value of x over here is 1 and value of x over here is minus 3 by 7. So if we will add alpha plus beta here, it will be 1 plus minus 3 by 7. If we will be taking LCM, it will be 7. 7 minus 3, that is 4 by 7 should be the sum of the zeros, and product of the zeros should be 1 multiplied by minus 3 by 7, that is minus 3 by 7. Now let's see, check it out over here. From here the sum of the zeros is coming equivalent to minus b by a. Minus value of b is minus 4, value of a is 7, so it is 4 by 7. From here we can see this value is 4 by 7 and this is even 4 by 7. Alpha beta should be equivalent to c by a. Value of c is minus 3. Value of a is 7. So product of the zeros should be minus 3 by 7. And over here we can see the product of the zeros is coming equivalent to minus 3 by 7. So hence proved both are coming equal. So we can say that we have verified that sum of the zeros from here, whatever the zeros are coming, if we will be adding these zeros, it is coming equivalent to minus b by a, and the product of the zeros is coming equivalent to c by a. Hope the concepts of the chapter is clear to you. Soon we will be coming with more videos based on the questions on this chapter and many more topics of mathematics. Thank you.